This is the Unit 4 Lesson 2 video, and this lesson is about angles and angle measure. The content center that we're going to be looking at in this lesson is understanding radian measure of an angle as the length of an arc on the unit circle subtended by the angle, and our mathematical practice is to reason abstractly and quantitatively. So in the past we've looked at angles that have degree measures. And in this lesson, we're going to draw and find angles that are in standard position, and we're going to convert angles between measures, between degree measures and between radian measures. So some new vocabulary for this lesson is standard position, initial side, terminal side, coterminal angles, and radian, central angle, arc length, and that's our list. So our first concept for this lesson is how you take the measurement of an angle. So what we're going to do is it says if the measure of an angle is positive, the terminal side is rotated counterclockwise. And if the measure of an angle is negative, the terminal side is rotated clockwise. So basically the concept here is when you draw an angle, you start the initial side, which they don't mention here for some inane reason. The initial side is always put at the origin and going out towards the positive x-axis. And then your angle, however many degrees it moves through, if it's positive, you go up and then counterclockwise. And if it's negative, you go down and clockwise. And you just move through the angle. And it's a good idea to reference the unit circle that's on the poster at the front of the classroom if you're not sure how to sketch a certain angle. So our first example, we're going to draw an angle that's in standard position. And part A says we need to draw an angle with a measurement of 210 degrees that's in standard position. So it's helpful when you have an angle, if it's more than 180 degrees, to break it down into 180 plus some amount, or if it's more than 360 to break it down as 360 plus some amount, because if a 0-degree angle is just a ray starting at the origin moving out towards the positive x-axis, then a 180-degree angle would be a ray starting at the positive x and flipping over to the other side towards negative x. So a 210-degree angle is a 180 plus a 30-degree angle. So we're going to be drawing an angle that's really 30 degrees counterclockwise past the negative x-axis. And so right here, if we start here on positive x, 180 degrees is just to the other side, and then 210 would be 30 degrees past that. So our angle would look like this, and we need to make sure we draw this red arc here with an arrowhead to point and show the direction that the angle is moving through. Part B, we're going to draw an angle with a measurement of negative 45 degrees in standard position. So because this is negative, we're going to make sure that we have to go clockwise down from the positive x-axis. And so our angle is going to look like this once it shows up. Right here, we're going down 45 degrees from positive x, and that's our angle. Make sure, again, you draw this red arc with the arrowhead. Okay, check your progress. Not going to show the answer for these, but you need to sketch the angle of 225 degrees on a sheet of paper and then pick the letter choice for your answer. Part B, we're going to draw an angle with a measurement of negative 60 degrees and then do it on your sheet of paper and pick your answer. Okay, example 2. This is a real-world problem about diving. It says, in a springboard diving competition, a diver made a 900-degree rotation before slicing into the water. Draw an angle in standard position that measures 900 degrees. So obviously, because this is more than 360, we need to figure out how much more than 360 it is. And so they've shown us that a 900-degree angle is 2 full rotations, 2 360-degree rotations, plus 180 more. So our angle, the terminal side, is just going to be a 180-degree angle, but we also need to include in our sketch the fact that we know that we've gone and made 2 complete revolutions before this 180-degree angle. And so our sketch is going to look like this. If we start here, we make one complete rotation back here, then we make another complete rotation back here, and then we make 180 degrees over here. Notice as you make full rotations that your circle, your swirl, is going to get larger, because otherwise it wouldn't be, if you just kept it the same and just kept tracing the same circle, it wouldn't really be obvious how many times you had made a complete revolution. So when you have to make multiple revolutions around, make sure you are increasing the radius of your swirl as you sketch it. All right, here we got to check your progress problem. This is about snowboarding. It's a 600-degree turn. So figure out how many degrees past the positive x-axis the snowboarder lands. So they're telling you, obviously, we make one full rotation, but how many degrees after you've made that is that arc right here, starting here and moving down there. Okay, example 3, called coterminal angles. Part A says find an angle with a positive measure and an angle with a negative measure that are coterminal with 210 degrees. So coterminal just means another angle that looks like the angle that you've been given. So we're finding another angle that looks like a 210-degree angle. So basically the way you do that is you add a full rotation and you subtract a full rotation. So a positive angle would be 210 plus 360, which gives us 570, and a negative measurement would be 210 minus 360, which gives us negative 150 degrees. And each of these angles, 570 and negative 150, are called coterminal with 210 because they look the same. Okay, part B, we're going to find an angle with a positive measure and an angle with a negative measure that are coterminal with negative 120. So again, what we're going to do is we're going to start with negative 120 and add 360. You can see here that they have forgotten the negative sign. So I need to get this to show up right here, negative 120, negative 120, and that makes these equations work. Negative 120 plus 360 gives us 240, that's a positive angle, and negative 120 minus 360 gives us negative 480, and that's another negative angle. So each of these angles, 240 and negative 480, are coterminal with negative 120. Okay, looking at check your progress now. We're going to do a part A and a part B. We're doing coterminal with 330, a positive and a negative. And now we're going to look at part B. This time we're doing coterminal positive and negative with negative 80 degrees. Okay, now we've got another key concept for the lesson. This is the conversion factor for converting between degrees and radians. So if you have a degree measurement, for example, 90 degrees or 180 degrees or something like that, and you want to convert it to radians, what you need to do is multiply by pi divided by 180. If you instead have radians and you want to convert back to degrees, you just do the reciprocal, 180 divided by pi. Is a really important thing that's going to show up a lot, so make sure you write this down in your notes. Okay, example 4, we're going to use our key concept. We need to write 30 degrees in radians. So remember, when we're going from degrees to radians, we multiply by pi over 180, and pi over 180 times 30, you can reduce the 30 and the 180 to be 1/6. So this ends up just being pi over 6 radians. So a 30-degree angle is the same as pi over 6. Okay, part B, we're going to write negative 5 pi over 3 in degrees. So remember, when we're going from radians back to degrees, we do 180 divided by pi. That will force the pi's to cancel out. 5 times 180 is 900. 900 over 3 is negative 300 because we have the negative sign here. So our answer of negative 5 pi over 3 is negative 300 degrees. All right, check your progress. We're going to do 45 degrees in radians. So write that down on a sheet of paper, work it out, make sure your answer goes into classwork, including your answer choice from here. For part B, we're going to do pi over 6 and convert that back to degrees. Again, write it down on your classwork page, pick the answer from this paper. Okay, this diagram that we're looking at now shows the degrees and the radians for common angles that you're going to see when you're dealing with trig functions. It basically shows you how to convert back and forth and what the common ones are. The most common ones are the 30 degree, 45 degree, 60 degrees, and 90 degrees, because the whole circle is based off multiples of those. So for example, over here, the 120, you could think of 120 as 2 times the 60 degree angle. So if it's pi over 3, it's 2 times pi over 3, 2 pi over 3. Or you could think of it as 4 times the 30 degree angle, which would be 4 times pi over 6, which if you reduce 4 over 6, you get 2 over 3. A 135 degree angle is 3 times the 45 degree angle. So if you did 3 times pi over 4, you would get 3 pi over 4, and so forth. It works the same way all the way around the circle. So the key is, if you can memorize these 4 basic ones, you'll be able to understand the whole circle. One more key concept. This is about arc length. It says for a circle with radius r and a central angle theta in radians, the arc length s equals the product of r and theta. So the length of this measurement, the arc around part of this fraction of the circle's circumference, the way you find that length is you do the radius of the circle times the angle. So let's look at an example where we try to find the arc length. Example 5 says the steering wheel on a monster truck has a radius of 11 inches. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? So the first thing we need to do is figure out what's the central angle. And we're making 4/5 of a full circle, and a full circle is 2 pi. So 4/5 times pi is 8 pi over 5 radians. And so that makes 4/5 of a complete rotation. So then we're going to take the 8 pi over 5 and multiply it by the radius of the circle, which gives us 88 pi over 5. I'm not sure why it doesn't, r is not being replaced with 33, r is being replaced with 11. And if you simplify 88 pi over 5, you would get 55.3 inches. So that point on the steering wheel travels 55.3 inches after 4/5 of a rotation. And real quick, we're going to take a look at a check your progress problem. This says the steering wheel on a yacht has a radius of 16 inches. How far does a point on the steering wheel travel if it makes 5/7 of a rotation? So follow the same process from example 5, work your answer out on your classwork page, and then select your answer from here. And once you've done that, we are done with Unit 4, Lesson 2.